Hello, in this video we will be looking at law of sines. So law of sines occurs when we are dealing with a triangle that is not a right triangle, such as these triangles we have down here. These two triangles are not right triangles, and you are going to be given values for within each of these triangles, and it will be required for us to use either law of sines or we will see later law of cosines. So law of sines, in a nutshell, the equation says sine of a over lowercase a. So that would be sine of a would a in this case would be the angle. A is the angle, capital A is the angle, and lowercase a is the side. Equals sine of the angle B over side B equals sine of C over C. So that is the law of sines in its most generic way, but as we will see later, it'll get more interesting, and it's not as easy as it looks here. We can't just jump straight into solving a problem just using this equation here. So anyway, so the two conditions that require the use of law of sines are the first one when we have two angles in a side, and that side must be known that is opposite of one of the angles. So if I knew, say, if I had two angles, well, if we, in this case, if when we have two angles, it doesn't really matter what side we're given. So it could be either one of the three sides, because we can't solve for angle B in this case, this angle here, based on the two angles that were given. We can do 180 minus the quantity of 45 plus 55. In this case, 45 plus 55 is 100, so the angle B would be 80, and then we can solve for B using law of sines. So that's the first condition, and then the second condition occurs when we have two known sides in one of the angles, and in this case, we have to know the opposite side of the given angle. So there is no other way to solve this problem using law of sines. If we didn't know this 10, for example, if this 10 say was here, if C was 10, then we couldn't use law of sines. We would need to use law of cosines to solve the problem. All right. So these are the two conditions that occurs. So law of sines happens is the angle side, or we know two sides and an angle, where we know one of the side opposite of the known angle. All right, so let's do an example here. Example 1, we are asked to solve the whole triangle if measure of angle B is 80, measure of C is 40, and the side B equals 14. All right, so that means then I can solve for angle A here. Let's make this bigger. So angle A then equals, measure of angle A equals measure of, or 180 degrees minus measure angle C plus measure of angle B. So equals 180 minus, so C is known here is 40 plus 80, that's B. So then this equals 180 minus 40 plus 80 is 120. So this equals B, measure of angle A equals 60 degrees. So that was the easy that was the easy thing that we just found, measure of angle A. That didn't require the use of law of sines, but now we're gonna have to use law of sines to find the sides B or A here, lowercase a and B. So those two, let's make those blue here. So we have B, or not blue, let's make them red. So B and then A. So those are the two major things that we need to find using law of sines. So let's solve for the lowercase a. That would be side A. So we can use law of sines and say sine of A over A equals sine of C. In this case, C is known along with the side. You have to use the known angle and its corresponding side. So 14. All right, so we can now plug numbers in. We know sine of A, so that, well, we don't know sine of A, but we know the angle. So this is sine of 60 over A equals sine 40 over 14. And from here, many people don't like to cross multiply, but that's what I'm going to do here. I mean, you can say divide by 14 on both sides and isolate A that way, but I like to cross multiply in these problems. So we have 14 sine of 60 equals A sine 40. A sine 40. All right. So from here, we can solve for a. That's what you need to find. So then a equals 14 sine 60 over sine 40. So this equals, I can now grab my calculator and see what this equals to. So I had a similar problem. I have a similar setup on my calculator already set. So I just need to change the numbers, basically. Oops, the calculator went away. All right, so we have, let's bring the calculator over here. So this is 14 times sine of, we said 60 over sine of, the other angle was 40. And we hit enter. So we get that side A equals 18.86. We're gonna round to 2 decimal places. So A equals, let's change the symbol. So this equals 18.86. So notice I have an equality sign here because this is an exact answer, and this is a approximate answer here. All right. So then now I can solve for B. Let's go up, or yes, for B using the angle C and its side again. So I can say sine of C over C equals sine B over B. So this means I don't know what the side of C is, but I know the angle. So sine of, let's go back up and see what that angle is at C. It's 40 degrees. So sine of 40, and its side is 14, equals sine of, let me go back up to see what B is. B is 80 degrees. So sine of 80 over B. All right, let's see if we can insert some space. All right, so we're solving for B. So cross multiplying, we have B sine of 40 equals 14 sine 80. So B equals 14 sine of 80 over sine 40. And this is going to equal, make it nicer, 4. So this approximates to getting our calculator. So we have 14 now. Just copy and paste that there. Change the angle to 80 and over sine of 40. Let me see what the side is. 14 sine 80. Yeah, that should be fine. So this is approximately 21.45. 21.45. All right, so we solved the triangle. So I'm gonna need to create more space. So we have A equals, or A is approximately, let's see what A was, 18.86. B equals, or approximately, is 21.45. And then we solve for one of the angles above. A, capital A, is, we said 60 degrees. So that's how we solve these problems. We will be given 3 pieces of information. We will need to find 3 more pieces of information. All right, so that's how we solve the first example.